So, hi everybody. Thanks everybody for coming to this Kotlin Meetup Munich of November. It's a pleasure to have you all of here again. And I think today we have such an agenda. We're going to have Fischer from the Stadtwerke Munich here in Bavaria. He'll be speaking about the company and the things they do here, with a lot of things with Kotlin, actually. So I think it would be interesting for you to know. Later, we'll have 3 sessions. Manuel Vivo, that from Google, is going to be talking about Compose for Android apps. Later, Raúl Hernández López from Twitter is going to be talking about Reactive apps with Asynchronous Flow and Stateflow. And last but not least, Mohit Sarveiya, Kotlin Google developer expert, will be speaking about Kotlin compiler plugins for Arrow Meta. And last but not least, Mohit Sarveiya, Kotlin. Good. So yeah, you will should be able to write comments anytime on the YouTube stream. We'll be able to read them. We'll answer them as we see them or at the end of the talk. But feel free to interact with each other. If you have any questions, just contact us. We have also our Meetup group where you can write any topic you want. So I would say first, Wolf, is your turn. You go with it, and best of luck for you.
Thank you very much, Enrique. Yeah, my name is Wolf Fischer. I'm a team manager from the Stadtwerke München, or Stadtwerke Munich. And we are a pretty strong development team, and we are currently actually looking for an additional Kotlin Android developer who helps us building a new product. This product is about multimodal transportations for a multimodal transportation service. That means we are building a mobile app that tries to connect the different types of transportations that are available in Munich. Everybody who lives in Munich probably knows the MVG More app, which is kind of the predecessor of this new product, which now also tries to interconnect the different types of services like car rental, bike rental, and our public transportation services. And we are, as I said, looking for an additional Android developer. It's actually a temporary position, so more or less it's suited better for a freelancer. So if anybody wants to join us and help us build this product, I would be very happy if you just write me. I will post my contact information in the comments later on. So just let me know if you're interested, and we would be happy if you can actually support us and help us build this new product. Yeah, that actually, if you have any question, just ask me either in the comments during the ongoing show or later on via email. Yeah, that's already everything that I had to say for now. Thanks, Enrique, for letting me capture your meetup, and then back to you, Enrique.
Thank you so much, Wolf. As he said, if you have any comment, just feel free to comment on the YouTube stream or on the Kotlin Meetup. And if there is any question, Wolf is there, so you can reach him out. Thanks, Wolf. And now it's going to be the turn of Manuel. Hello, Manuel. Manuel will be talking about Compose for Android. So I think you probably know him from Twitter and several other Android channels. He's definitely working on some hot topics right now. So Manuel, the stage is all yours.
Thank you, Enrique. Thank you everyone for joining the talk. I'm Manuel Vivo and I work as an Android engineer in the developer relations team at Google. As Enrique said, I'm currently focusing on Compose, Kotlin, and coroutines, and also dependency injection in Android with Hilt and Dagger. So I want this to be very interactive. So This presentation, Compose for Existing Apps, is available on the internet. So I want this to be more kind of a one-to-one with all of you, or one-to-many in this case. And so if you have any questions, feel free to post them here. I will answer them. This is because, as I was saying, like the presentation, you can find it online, and probably the best use of both our time, your time and my time, is to answering your questions that you might have. Yeah, I think I can see David there. So yes, please, I'm gonna try to cover the presentation pretty quickly to have more time for questions. So yeah, let's get started. So I'm gonna be talking about Compose for existing applications. So we're gonna see different APIs and see how you can integrate Compose in your app that uses the view system at the moment. And that's how I'm gonna refer to the way of developing Android apps at the moment. And this is gonna help you, migrating gradually in case you need it, etc. So for those who don't know what's Compose, Compose is a modern declarative unbundled UI toolkit for Android, and it's completely built on Kotlin. And now it's in alpha. We released last week alpha 07, and it's pretty much ready to play around with it. We are not expecting to have that many applications in production, but of course the time will come next year. With Alpha, we released a bunch of samples that you can find there in that link. And basically, it's a way to showcase what you can do with Compose. So here you can see 8 samples, like with different layouts. For example, you can see a calendar on the screen that is built with Compose from scratch. You can see like a kind of a Noobs-like app, or like with blog posts, like a chat app. Obviously, nothing surprising coming from Google. So you can see like different applications and get some inspiration from these samples that we released at Alpha. Just to show you like a little bit, sneak peek, in case you are not familiar with Compose, how much it simplifies Android development. Like imagine, you think how many lines of code you need to write in order to have a recycle view on the screen? So this is pretty much the code you need in Compose. So with Compose, you can have this lazy column for composable. Everything in Compose is a function. It's a composable function that this is gonna emit, or this is gonna tell Compose what to show on the screen. So basically here, if we wanted to have some sort of like recycle view type layout, here we can use a lazy column for passing in the user movies, for example, and then displaying the text, the movie title on the screen. Pretty simple. So I hope you are very excited about Compose. We are really excited about it. And of course, like if you have your existing app, you might want to migrate it to Compose. So there are different strategies to achieve this. So the first one, of course, is when adopting a new technology or a new library, you might be doing that in new screens. So for example, in Compose, because it's related to UI, so you say, okay, I'm gonna build a new feature, let me build a new screen, and that's it. So you can do it, and you can do it using Compose. And in this case, you will interact with the view system at the edges, because the rest of the screen will be using the view system at the moment. Then there is other scenario where you can have Compose and views used at the same time. So you can have, for example, a recycle view that we saw before with items being in Compose, or the other way around. Like you can have a lazy column and then the items being in the view system, because you might have a custom layout or something like that, or a custom view. So we will see like how to do this later. We have different APIs to achieve this. And of course, like the last thing to do is migrating something that you might have. For some reason, you want to revamp it. You want to make it cleaner and more, readable. So you can like do basically and refactor the whole thing to use Compose. The same thing, like it will use the view system, will interact with the view system at the edges until like the whole thing, the whole application uses Compose. And with the samples, like we have something that could relate to these different like kind of migration strategies. So the first one is Jet News. That is a Compose only application. And so this is not really like building new screens, but this is a completely built using Compose. And in the middle, we have Crane, which is another sample app that it uses Compose, is built with Compose from scratch, but then it uses a map view, which is an actual view, and that's also integrated in Compose. So the outer layout is Compose, and here we are using a map view because a map view is not available in Compose yet. And then we have TV that Chris Baines is migrating to Compose as we speak. So he's been like working on TV for a long time, and now he's migrating all the screens to Compose and see like how we can get the most out of Compose. So next we are gonna see a bunch of APIs with which you can achieve all of this. So the first topic we are gonna talk about is Compose in Android views. So how, for example, if you are building a new screen or something, how you can have Compose there. And then, so the first thing is like, if you want to create a new screen and you want to use it, use activities for that, actually we have an extension function for activities where you don't actually need XML code. So you can create your example activity and you can call set content. That's gonna make you be in Compose land. So inside set content in an activity, you can call like composables, and you can have your material theme, you can have a surface and display something on the screen. But obviously this is quite a niche scenario. We are only using an activity to create a new screen. What if you have a fragment, or you want to use Compose in part of the view system tree? And for that you have the Compose view, which is a view. And this is an Android view that can host Compose UI content. So for example, let's say you have this fragment in your app using a coordinator layout and few things. And if you want to use now a constraint layout and want to replace all of that and the content within it with Compose view, you can actually replace that with a Compose view. Basically, you give them kind of pretty much the same attributes, the width and height of the layout, etc. And with that Compose view, you can actually get it in the fragment whenever you inflate the fragment or whatever, and then you can find the view there with Compose view and call set content in it as we were doing before. And with this, it will be pretty much the same. Here, you're in Compose land, and you can call text or whatever and display something on the screen. But then things can get more complicated, and let's say, for example, if you want to have a Compose at the root level in your fragment instead of in one part of the screen, you can do the same. You don't actually need XML code. You can create a Compose view in line and then calling set content, and pretty much the same thing. But then, things can get more complicated still. And let's say you have multiple Compose views in the same tree layout. What you can do is that, well, actually, first you can do it. And the second thing is that you have to give them unique IDs. And this is in order for saved instance state to work, as we'll see later. If you want to restore state across process death and all that, or recreation and all of those things, you have to give them unique IDs. You can do it like that. Cool. So now let's see the opposite thing. So now how can you have Android views in Compose? For example, let's say you want to reuse your custom view that took you ages to develop, or you want to have views that are not yet available in Compose, like map or web views, as I was saying before. So for that, you have the Android view composable. So this is you calling, you were saying, an Android view inside Compose. That's why this is a composable. So this is kind of the form it takes. So you basically pass a view block. This is kind of like a view factory. And then you get the callback and update callback to do what to do when the view is being inflated on the screen. So we're going to use Crane as an example. So this is kind of a trouble app that is part of the material studies, and you can find in the link that I mentioned before. And in Crane, when you tap on a destination, it will show you where the city is on the map. So here you can see that obviously the rest of the outer layout is composed, as I was saying before. So Madrid, Nonstop, etc. it's in Compose. And then we have the map view embedded in it. This is because the Google Maps SDK for Android doesn't provide the composed version of the map view yet. So we need to use map view, Android view for this, sorry. So let's say we are in our composable function, and then inside here we can call Android view. So we are creating a map view with the remember map view method, something like a helper function that we ourselves create. This is part of our code. And here we create a map, remember the map view, and then we pass it to the Android view in the Lambda, because it's kind of the factory. And then in the map, and the callback here, the update callback, we get like a callback to do what to do with with the map view whenever it's been inflated. So following the documentation, we call map get map async, and here we place a position, we add a marker on the screen and move the camera. We don't have to do anything else. But the good thing about it is that you can also interact with the map view or with Android view and compose seamlessly. So you can see here that the zoom control buttons are in compose, and you can modify the map view. And so you can see also that you can interact with the map view. You can move the map around and all that. And that's because something it's very interesting. So let's say we have the same map view container, the same code that we had before. But now we kind of add the zoom control buttons that we had, and this is actually compose code. And we have this zoom variable that we save with saved instance state. And so whenever you tap on the zoom, that's gonna update it. So how can we tell Android view to update whenever that changes? And this is basically in the update lambda. And whenever a state has been read inside it, it's gonna recompose Android view, and it's gonna kind of trigger again kind of the relayout in the map view that we display on the screen. That's why this is able to actually recompose and show the new information. But as you are seeing, like the map view is being created programmatically. What if you have an XML layout that you want to reuse? So for that, we have the Android view binding composable. Obviously, this requires to use view binding in that XML code that you have. And this ships with a different artifact. So we have the UI-view binding artifact that you have to pull in. Basically, to use the Android view binding composable, you just call the inflation of the binding of your layout. You pass that as a parameter, and you can access the binding in the update lambda. Cool. So this is for everything for this topic. In case you want to have either compose in your Android views or vice versa. Let's see. I hope we don't have any comments. Yeah. Good evening, everyone. So cool. So let's move on. Let's talk about resources, how to access resources in Compose. So basically we have a bunch of helper methods. So for example, we have string resource in case you want to access static strings, but also we have support for formatted strings. So for example, you can pass in string resource, whatever. But then here, let's say plurals are not supported from the Compose library itself. So you need kind of like a escape hatch. So here, basically, in order to get plurals, we need to access the resources that are available in the context, and from there you can get the quantity, and you pass in the string ID, etc. So here, this is kind of, as I was saying, like a escape hatch. And this is something that we will see later more about this. Is the context ambient that now in the new version is being renamed to ambient context. But basically, kind of an ambient is a way to, in this case, the context ambient gives you a way to access the context whenever you are in a composable. And that's going to give you the context that is closer to your host Android view. And with that, with the context ambient, we can get the context, and we can get the resources, and we can get the string that we are interested in. So we also have support for dimensions with a method dimension resource, and then that you can use in a padding later. Pretty much the same for colors with the color resource method. And then we have also support for vector drawables and bitmap drawables. Now you can check in Compose, there is not this sense of drawable anymore. Like now they are called vector or image assets, or painters in that case. So for example, if you have your XML vector resource, you can get it with a method vector resource, and image resource if you want to get a bitmap from the drawables folder. And there is not a common way to load, as I was saying before, like there is not this drawable class that we have in the view system, and this is designed like this for a reason. One of the things to take in mind, to keep in mind here, is that these are gonna decode or parse the drawable on the main thread, and this is because this is how the view system works. But in Compose, like we can do better, and we have support for asynchronous resource loading, and these are gonna load the resource on the background thread. So instead of calling image resource, now we can have the method load image resource, that this is gonna give us a deferred resource. And so in here, it will, thanks to Compose and the recomposition engine behind it, like here you can have, deferred image resource, and you can put inside what you want, for example, the image. And whenever the image is ready, this will recompose and show the right image on the screen. So we don't have to do anything else. And the same support you have for vector resources, but this is with the load vector resource method. Cool. As I was saying, there is at some point you will hit some roadblocks wherever you cannot do something in Compose, but you could do before in the view system. And this is because Compose is still in alpha. We are trying to figure out different APIs. And to do that, you can use the escape hatches I was talking before about ambients. So here you have a context ambient, a view ambient, and the lifecycle owner ambient or configuration ambient in case you want to know if you are in landscape or portrait mode. So this is kind of the escape hatch that you can use. Cool. What about app architecture? Let's say you are in the process of migrating, you have your screen with a particular architecture, or actually you have your whole application with an architecture and you want to be consistent. So the thing is that pretty much everything works with Compose. So Compose actually favors unidirectional data flow. And so you can have the architecture in your application easily. We're going to see that we are also providing helpers for libraries that integrate quite well with Compose. The first library that we want to talk about, it's a view model library. So you have this view model composable function that is going to return an existing view model, or it's going to create a new one in the given scope. Well, what do I mean with the scope is that it's going to follow the activity or the fragment lifecycle. So it will be retained as long as this scope is alive. So for example, if you want to use this in an activity, view model will return the same instance in all composables. So let's say like your whole Compose UI is in an activity. It doesn't matter if it recomposes or if you create new composable, all the view models are going to follow the activity lifecycle, meaning that you will get always the same view model. So this is something that we want to improve. At the moment, you cannot scope a view model to a composable. That is ideal in some cases, but this is something that we are exploring. So for example, if we go back to our application crane that we saw before, this is kind of the view model that you could expect from the application, kind of the main view model, where you are going to have suggested destinations, and then they are going to be exposed as a live data, as we will see later. So basically, the way that we could access this from a composable function, we could get, we are in our crane home content, and we can get the view model just by calling view model. That's it. We don't have to do anything else. So this view model function also takes a factory in case you need to pass some dependencies to the view model. You don't have to do anything else. But also we have extensions, as I was saying before, for working with live data, Flow, and AnexJava. So each of them are available, of course, in their own different artifacts. And this actually, when you call this method, it will register the observable. So it will register that composable as an observable and will represent the values as a state. So that state is gonna update whenever you emit a new element to the flow, or you post something to live data, etc. So every emitted value will cause a recomposition in those places where state.value is used. So for the example, we are going to use live data that you can find in this runtime-live data artifact. And for example, before we had this the view model in our crane home content, so you can do view model suggested destinations, observe as state. And destinations here is going to be a state. And so if you pass that state to, for example, explore section, every time there is a new emission, if explore section reads that state, it is going to be recomposed. So that's pretty cool. Only one method. I'm seeing a question about images from network. I'm going to cover that in a second. Cool. So app architecture, other stuff like apart from having the state in a composable function, so that it recomposes and Compose can remember that mutable state that you might have in your composables. You can also use saved instance state when the activity or the whole process is recreated. So this pretty much works in the same way that it works in the view system at the moment. So it supports, as you might expect, like common types like strings, int, floats. Basically, everything that you can put in a bundle can be saved with this method. But then imagine you want to do something different. Like, for example, we want to store this city data class that you have, the name and country, for example. So the easiest thing to do, obviously, this cannot be bundled as it is right now. So the easiest solution is to make it parcelable. And you can use the parcelize annotation, and in this way the object is going to become parcelable and can be bundled. So you can use it with saved instance state automatically. But for some reason you might not want to use the parcelize, or you want to do something on your own, whatever. You can do it manually as well, and you can do it using a saver. In the saver, basically you convert an object into a set of values that you can put in a bundle, and then you can get it back. So for the example, we are going to use a list saver. And so in the save lambda, we let compose know how to convert the city object to a list of values, of string values in this case. And then in the restore lambda, we describe how to convert this list back to a city object. And basically in the saved instance state method, you pass in the saver, and that's pretty much it. You don't have to do anything else. Cool. Testing is really important. So we've written a lot of compose code. Probably we migrated a few parts to compose. Actually, you have to verify that everything that you've done is correct. So you have to make sure that you haven't broken your app. And for testing compose, there are great talks available online. But basically, you have this method create compose rule that is gonna let you test compose code. Basically, you can use it in your instrumentation tests. So here, let's say we are in our create compose test, and we can have the rule in the method. And now here in our test body, we can call test rule set content to actually call the composable that we want to test. And basically here, for example, let's say we want to test the explore section composable. We call it inside set content, and then we can use the compose testing APIs to assert for something is on the screen. The good thing about this is that apart from compose testing APIs, you can use Espresso. And this is because both frameworks can work at the same time to test your application. And in fact, Espresso will wait for compose to become idle. So for example, here, if we are testing the screen that we saw before with the map on it, you can call, on view, Espresso APIs with the ID of the map, and you can check that is displayed. If you are familiar with Espresso, you know that this is Espresso code. But also, if you need the activity rule, in some cases, you need to use the create Android compose rule instead. So for example, here, if we want to test the details activity, kind of the city details, and we want to access, for example, the camera position that is inside the map, inside the map view, what we can do here is that you can do, within that test rule that we saw, you can get the activity rule. With activity rules, you can get the scenario, you can get a callback for when the activity is ready. And now you can, synchronously, you can get the camera position from the map, and you can assert that is correct. So if you need the activity rule, make sure to use the Android compose test rule. Cool. Navigation. We released a new navigation library for Compose quite recently. It was in alpha a couple of weeks ago, but now you can use it. I think it's 0.2, so alpha 02, so you can use it. And the main composable for navigation is the navhost composable. And this is going to create a new navigation graph inside Compose. And basically, pretty much, this is how you can define different destinations in this navigation graph with the composable function. You can also have the start destination. But then, because you might want to, be able to navigate to other destinations, etc., for that you can use the navigation controller. Basically, this is kind of a common Compose pattern when you remember that navigation controller that you passed to the navhost as a parameter. And then you can, for example, when the user taps on an icon, you can call navigation controller navigate to this destination, and that's pretty much it. But also, if you want to access the navigation controller from deep inside the hierarchy tree, you have the ambient available for that. So it's an ambient, you can think of it as pretty much a service locator. The dependencies like travel down the tree. And here you can have ambient nav controller, you can get it and you can use it whenever you want. But we recently added new shiny things. So we added support for navigation arguments. So now these are kind of string-based at the moment. So for example, in your destination, your composable, you can say, hey, I have an argument, which is the user ID. And actually you can get the user ID with the backstack entry easily and pretty fine. And also, we also have support for deep linking. So now this composable as well, you can have a list of deep links, and that's pretty much it. It's supported. Take a look at the documentation that we recently released, and everything that you need is in there. Cool. Themes and styling. I'm going to go pretty fast through this to leave more time for questions. And so we have, theming, kind of material theming as the kind of material guidance to go in Android development. And we have a few things like, so I was saying, like typography, shape, and colors. It's pretty opinionated in the way you have to use that. So themes in Compose, as I was saying, are also composables. So here, dark colors, you can get kind of the palette of colors for your MDC theme. And basically, you can give that color palette to the material theme composable, and also you can specify typography, shapes, etc. But now let's get into the interesting situation, because you might have a theme like this. Probably it's like 600 lines of code or something like that. This is the code that we have in insane code. You are not expected to read this. It's insane the kind of the amount of theming that we have in the Google I/O application. But if you want to convert this to Compose, you might get like another theme, made for Compose, which is also quite big. And the problem here, if you are doing a migration, is that you're going to have multiple sources of truth, and that's going to be a problem. So it might be not necessarily a bad thing in the future, but it's not ideal. So if your plan is to migrate to Compose in the future, ideally you set that in Compose, and then it works back to XML and to the view system. But this is not possible due to the limitations of the view system, because you cannot modify themes at runtime. And so basically something that we came up with, it's the MDC Compose theme adapter that I recommend you to take a look at. And basically it works the other way around. So given your XML theme, you can import it in Compose, calling MDC theme composable, and that's it. And that's going to read the typography, the colors, and shapes. So basically, if you want to manually control it, you can also use the create MDC theme, passing a context. So there are a couple of restrictions here. I'm going to go through very quickly. Only works for the MDC library for versions 1.1 and above. And basically, for example, as we are going to see, I'm going to see now, it doesn't read the default widget styles. We're going to see what that means in a second. So imagine that you have this default widget style in your XML theme. You have a button, like awesome button, very fancy, with a stroke of the border of 2DPs and the secondary color. The thing with Compose is that Compose doesn't have that concept of default style. It doesn't really have it. We just have a button. So how can you do this in Compose? So basically you would do something like this. So for your in this case style, that is you call it my app button, for example, you will have a composable called my app button. So this is kind of the equivalent to having the theme declared in the XML. And now here, the parent style is going to be a button, as we were saying later. And the border, you just specify that inside it. You have the stroke width and a stroke color. So you don't actually need a default widget style. You just can call, my app button instead of button in the code you want. And that makes it reusable. Cool, it's going to be, almost half an hour. I'm going to speed up to leave time for questions. Please add questions. I'm going to answer them now. Fonts, are you asking for downloadable fonts? We don't have them yet, so that's gonna come in the future. So in case you need to use downloadable fonts, just download them in your project and put them in the REST folder. That's pretty much what we can do at the moment. And then you can create a font family and pass the font family to the typography and to the different text styles. Cool. I saw a question about image loading. Yeah, we came here. So we have this library at the moment maintained by Chris Baines called Accompanist. And basically, we have support for Coil and Picasso, and I think we are planning to add more support here. So basically, it is going to use either Coil or Picasso under the hood. And basically, you just call it like this. You call it Coil image, you pass in the data, where you want that information to come from, and you can scale, you can do things like fading. So it's pretty useful. So imagine the amount of code you need in the Android view system to actually show an image on the screen. Here you have a composable, it's just one function. And that's going to fade in. Cool, and that's the end of the presentation. So for more information about migrating to Compose, we have a code lab. As I was saying before, we also have TB and Sunflower. So we have a branch in Sunflower that we have one screen, the details screen migrated to Compose. For more general information about Compose, we have the samples, as we said before, we have the code labs, we have the documentation. There is also a pathway that if you want to get started with Compose, you can take a look at the pathway, because the pathway is going to go through, the basics, and it's going to, in like a step-by-step format, it's going to show you everything you need to know about Compose. And please, this is alpha. Give us feedback. So we have a Compose Slack channel there you can find, or you can submit bugs to Buganalyzer and we'll take a look at them. Cool. Thank you so much. I'm gonna be here listening for questions. Thank you all for joining. Oh, by the way, if you need, I think, let me put the the first slide. If you have any questions, because you are gonna watch this offline, not offline, but in a couple of days, please reach out to me in Twitter if you have any questions. I'll gladly answer them.
Thank you so much, Manuel, for the presentation. I think Compose is right now a topic hot enough to hear as much as we can from it. If you folks have any questions,
yeah, it can be about Compose. It could be about anything, coroutines, dependency injection. This time is for you.
Use the chance, folks. We don't always have Manuel on our meetup, so if you have any problems on your apps.
I see a lot of familiar faces in the comments, but they have no questions so far.
So we have one from Stavro. Does the Compose view model function works with fields annotations such as view model factory?
Yeah, and it's great. So the other day, I actually migrated Crane, the sample app that you saw before. I migrated it to use view model and to use Hilt. So before, Crane was kind of in a weird state because it didn't have an architecture in place. But even though we are using fake data, I created some repos, data sources, view models. And actually, it was so easy to inject the view models into the composables because you annotate them with the @inject view model annotation. And that's it. You can use it. I mean, you call view model in your composable, and that will grab the view model that Hilt it's going to create for you. So it's pretty neat. You have to try it out. And if you want to see an example, you can check out Crane as an example for that.
So more questions, folks. Otherwise, I'll start with a couple of them. You've mentioned that Compose is supporting Espresso for testing. What about foreign frameworks such as UI Automator or Appium? Is there support for them?
I don't think so at the moment. I mean, if they use Espresso under the hood, you might try them to use Espresso to communicate with Compose, but I don't think we have any things like that in place. For example, UI Automator, I know they also do some accessibility stuff, and they can do able to check for accessibility and things like that. That's not at the moment supported in Compose. And that will come in the future, I guess, because the accessibility story, it's a little bit rough at the moment, and we are trying to improve it for beta.
Okay. Maybe another question. You've mentioned the topic of interoperability. So as long as we're defining view bindings, we should be able to talk with former XML. What if
Yeah.
so if there is any library that is pure UX library and is not defining view binding, is there any chance to use them, or should we rely on the libraries implementing view binding?
You can use it, but it is a pattern that we don't really want to promote here in this kind of talks. So basically, you can use it's something that we don't have in the examples because we try to avoid it as much as possible. But if you remember, the Android view composable took the factory of the view as a parameter. It was called view block, and actually that view block gives you the context. So with that context, you can get and inflate anything you want with the layout inflator. So you can actually use it. We are trying to discourage it in favor to use view binding, but it is possible.
Okay, we have a couple of questions more, Manuel. Miguel says, we have mutable stateflow and servflow. Why not a mutable flow class that could mimic public behavior or public subject, sorry?
The public subject. So you can pretty much do anything you want. This is coroutines related, but you can do pretty much everything you want to do with servflow and stateflow. I don't know why you wouldn't create something like that yourself.
Okay.
Servflow you can give the number of replies, for example. So if you don't want it to replay anything, you can put a replay of 0, and it's not gonna do anything there.
Okay, then another question from Dimandas Gupta. Are we going to have Anu compose scope built in the future?
What is Anu?
Diman, if you're there, to clarify.
I think I know what he means. So basically, the ability to scope a composable to Hilt. So I was saying, for example, at the moment you cannot scope a view model to a composable, and it's pretty much the same with Hilt. Kind of the root component or kind of the dependency container that you're gonna have is gonna be scoped to the activity or the fragment where compose is used, and this is kind of giving the fact that you can scope objects to a particular composable. This is TBD at the moment. We are trying to explore the best way to have Hilt fully working with Compose.
Okay, thanks. We don't have any more questions. I might have another one. So Compose is still alpha, right? What are your thoughts on? I think in the real world, there is always this discussion. Should we include alpha or beta libraries? Is our company gonna live through a library that is in alpha state? Should we bet for that? Should we not? What are your thoughts regarding Compose? Should we bet for that?
Yeah, so I'm actually pretty involved in the process of documenting the different APIs, not the documentation itself, but the guidance and everything we are giving to developers. And one of my main points that I try to raise with the team is the fact that we have to be very explicit on what Compose cannot do. Because it's quite easy to get with the hype and say, hey, Compose is great. But as I was saying, like there is some rough APIs, or kind of more like rough components, like accessibility story. That at the moment, it's in a weird state. I think we need to make a lot of progress to put it up to what's the view system at the moment. So I know, I think like you can use it, but you need to know the limitations of Compose as of today. Also, if you adopt it in production, for example, expect a lot of API changes. I mean, Compose is functional. You can say it in the examples, etc. It will perform better in the future. But you have to be conscious of API changes can happen because we are in alpha, and some functionality might not be there. One of the kind of things that we get a little bit of pushback from big companies trying to adopt Compose at the moment is the fact that you have to use the canary versions of Android Studio. And that's obviously a blocker for bigger teams that wants to use the stable version. That will come in the future if you are comfortable using canaries and your team is okay with that. I mean, I think that's one of those things that when you try compose, you don't want to go back. But of course, that will come with time, and we need to do a pretty good job with guidance as well, because I mean, you have to train your team to use Compose. The mental model is slightly different. That's why we also provide guidance and documentation to get you think about Compose, like those states. What do I mean with a recomposition? Things like that. So if you have any requests for more code labs, more guides, more documentation, whatever, please, it is the time to ask, because we want to get into a point whenever we hit 1.0, that everyone has the resources they need to learn and start using Compose.
Okay, thanks, Manuel. I think, folks, we have time for one more question, if you can type it. Otherwise, I think Manuel is open enough. You can reach him on Twitter, or I think it's probably easy to find his contact information. So I guess, Manuel, they can reach out to you if they have any question or topic they want to clear.
Absolutely. Thank you so much, Enrique, for inviting me into the conference. It's been great. Thank you so much.
Thank you so much, Manuel. It's been great to have you here. And then I think we could jump into the next speaker, which is going to be Raúl Hernández. Hello, Raúl.
Hello, Enrique.
How are you doing?
I'm good, thank you. Excited.
Yeah, thanks for being here. It's always a pleasure to have interesting people on our meetup. So Raúl, you might know him from Twitter and his blog on Medium and stuff. He has been writing lately actually a lot about reactive apps and flow and coroutines and stuff. And yeah, he's going to be talking today about full reactive apps with asynchronous flow and stateflow to communicate with UI. You have a few articles on the topic. So if you want to Google for his name, you'll find his Medium account, and you can see his entire history on this topic. I think you've actually been researching a lot, so I think it's nice because you know what you're talking about, and you've probably be hitting a few stones on your way until you can reach this state on your research. So yeah, I leave it up to you, Raúl. The stage is all yours. And folks, again, if you have any questions, just feel free to write them on the chat, and Raúl will probably check them on his during his talk. Raúl, good luck.
Thank you. Hello, everyone. So yes, Enrique mentioned I'm gonna talk to you today about full reactive apps with asynchronous flow and stateflow to sync with the UI. So that's myself, that's Raúl. I work at Twitter in the search team, and you can follow me here if you want to know more about the articles I wrote and the different things I am following up and trying to discover myself. Also my GitHub, where you will find also the samples that I have on the lists of this. But let's go to the agenda of today. Today, I will explain you, first of all, the use case that for everything that makes sense to me and why I wrote this talk and the different articles. Then I will introduce you the migration strategy I think is quite useful for you to follow if you want to go step by step. Also, I will go very quickly to the basics that I feel are quite important to try to understand things before going directly to implement it any code. And then, and then I will go to the implementation section, which is actually the longest section of this presentation. That's going to be actually the hardest to probably follow up. And then in the end, the lessons learned and the next steps, if there are any. So first of all, I will introduce you this use case. And the use case is basically this that you can see here. It's basically a sample app I built like 3 years ago, a very legacy app, where you can see I was starting to type tweet with flow, and you can see also a detailed view right here when you click in one of those results coming from the search. But basically, the search mechanism is having different states, like if we are having an empty state, or we are having any results, or we have the loading screen as well. So it's simple enough. So I thought, why not to change that to have flows and more things? So for that, I thought, and I also planned myself to do a migration strategy because I think this is interesting when you are in a team. For that reason, when we think in a very legacy project like this was, we need to refactor a lot. And then following some steps for that. For instance, first of all, if we have any previous architecture, probably we don't want to get rid of that architecture. So you need to actually analyze what you got at the moment and then introducing next things on the top of that. And for that, what I had is, you can see here, the data layer, which is composed by the repository controlling different data sources, that's the network and the database data source, all built from the ground up in Java. And then this communicating with the use case, that is requesting things to the repo, it's not caring about where is this coming from, and then the repo is returning the results back to the use case. This is actually the clean architecture side. And then this use case is connected with the presenter, that is the model view presenter layer of the presentation. And this presenter is actually executing the use case and starting this process. The results are coming back by means of callbacks in this case. And actually, you can see here in the views that you have the callbacks inside them because those are coming from the use case, drag those to the views. And the views actually are connected with the user because the user, when he's typing this query, is actually triggering a mechanism that I built with a view delegate that is helping the view to have responsibilities out of the view, and then with the view listener, listen to those queries typed by the user, and then starting this mechanism towards the presenter. So that's basically this all built from the ground up with Java. But then also we need to make sure that we are making a good compatibility with the different components we had earlier. That means backwards compatibility. And by that, I mean RxJava. In my case, RxJava was quite deeply there. So that means that we need to make sure that when we are migrating different layers, we need to make those coexist together. By the time being, I'm making sure that everything is backwards compatible, actually. So we need to make sure that we understand the different pinpoints and the different connections to make sure that everything is well connected. And by that, I mean, those are the different points that I had at RxJava. That's the repo, that's the data sources, until the use case where this is subscribed and we are collecting the results. But also, I have another stream coming from the view delegate, because this is, for me, a hot observable. Every time I am typing a query, I need to pass in and start this mechanism to happen. And then, starting this migration, I thought it would be a good idea to be starting from the data sources. That's the deepest layer of the data. Then changing those things, including some calling already because I didn't have any. Then the same with the other data source. And then making the same with the repo. If you see, I still have those things from RxJava. That means that I am returning the results back as singles or observables, because we don't want to change everything at the same time, do we? Then when we have everything changed on those layers and the next layer is ready to use those results coming from the deepest layers, then we can start changing those things and just returning the results types that we are expecting to have. So you can see the repo is there with RxJava and Flow, and then changing that to Flow when this is prepared to be used. And then the use case is exactly the same. When we are migrating from RxJava and we don't need to have those coming from the different things with observables, then we can change this to have observables, no flows, actually. And finally, we need to change also the view delegate, because this is a hot observable. That means for me, a public subject or maybe a behavior subject. So then for that, I need something like channels. But then if we want to go a step forward and then changing also the callbacks, is that even possible? So for me, that would be nice to be just with Stateflow, because then we can just change those things and wrapping the things with Stateflow and making sure that the view is not having any callbacks coming from the different deeper layers like clean architecture. Then because everything in the views still is in Java, actually, because Stateflow can jump between different classes Java and Kotlin, we need to actually process and collect the results. And you can see that the view is using Java. So I included something else, a friend of that view that is actually composed by Stateflow handler. And the Stateflow handler purpose is not is just basically collecting this thing. But because it's a suspend function within a coroutine and everything is with suspend functions or coroutines, that means that we're going to need to have this in a Kotlin file. That's why I introduced this little friend right there. But let's see very quickly a few benefits I think this is including for us. For instance, if we include those things and those layers between and across different components and elements, we can reuse existing elements that we had already in place. That means we don't have to become crazy and changing everything at the same time, because it doesn't make sense for big teams. And also because we use this kind of mechanism I explained to you that is super easy to follow, and it's just a black box kind of approach, we can just introducing certain inputs and expecting certain outputs for the next layer to work with that. So let's go now a bit quick to the different basics that for me are actually the things that we need to understand very good to master this and going from the ground up. So let's see. First of all, very quickly, what is an open stream? By now, probably most of you know what is an open stream, but for me, an open stream is something like that. I say right now, hey, Vulkan, to you, and then the other person that is in the other side, doesn't matter if it's a messaging application or just real life, is answering to me like, hey, I am just right now teaching some maths and learning myself something new because it's so cool, and this can finish right here. Then it will be a closed stream. But if the conversation is actually happening for a while and we have this open, that's what we call open stream, because we don't know when it will finish, actually. As simple as that. But then, what if we open streams are not needed and we need something else? What shall we use in our case for our implementations? For that, we could use simply one-shot operators and one-shot operators, actually. For instance, in our Java, we will use single, don't we? And then if we need to change this with coroutines, we'll use span functions. So the equivalent from Java single to coroutines will be suspend function returning an object that is not nullable. But for the case of maybe, we'll wrap this with a maybe here. And this means that we'll need a suspend function returning a nullable object. Then finally, if we don't need to return any object for this type, we will just have completable in our Java or suspend with unit. That means in Kotlin, as all you probably know, that we don't have any value to be returned. Cool, so we know the types that we need for one-shot operations. Let's go to threading. To compare the threading, we use settlers in our Java. And the equivalent to that is dispatchers in coroutines. This is going to be actually used for flows, state flows, suspend functions, and so on. Then lifecycle. This is actually the most relevant thing to me for the basics, because we're going to manage the lifecycle of our Java things with disposables. And then if we need to do the same with coroutines, it's going to be called scope. But the scope actually has superpowers that are above any power that disposables have. What I mean by that, we have start token currency that is super nice. And that means that if you use start token currency, we can actually make sure that we are cleaning recursively different resources by just doing a few things that we're going to see in a moment. But let's see a case of cancellation. When we have the scope, this scope is being canceled, and this scope is like the father of different processes below this scope. That means if we cancel this scope, we're going to cancel all of them. Those processes are going to be canceled. And this is very cool because you don't need to separately dispose of any of those like we will do in our Java. So that means we want to avoid memory leaks by using start token currency, which is super cool. Also, another use case that I use in my sample, and that's why I explained this actually, is a scope plus supervisor job. What's the difference? For me, this is interesting because we can avoid side effects on cancellation. That means avoid other children's cancellation. By that I mean, process 1 has thrown an exception. So that means that probably we don't want process 2 and 3 to be finished because maybe the other processes are interesting for us to be there. at the time that we have any problems with the other process one. So if we include like the root scope plus supervisor job, and we cancel for the wrong reason because this exception happened process one, we won't affect the other children. So that's the cool thing of using scope plus supervisor job. Now let's see the implementation following up this plan that I mentioned earlier. You will notice that I include a kind of overview for every single section. So that's like a little recap that we will see from this implementation. But now, Gradle dependencies. I use for this sample app Kotlin coroutines. And when I was updating this sample app, I went to 140. And 140 is super interesting because it's actually stabilizing Stateflow plus Sarveiya. And Stateflow is one of the things that you will see today. Then for the standard library, I also use 140. Then let's go to the data sources design and the migration of the network and the DB. So as you can see here, I'm gonna migrate to cap suspend functions instead of singles. Because for a network request, probably you don't need more than one sort of operation. So that's why I use that. Now, in the network data source, what I have is just a retrofit object with API and some helpers for that to handle the connection handler, or to get some transformation for the requests or responses. Now, what I had at time, as you can see here, this Java, I returned a single with a list of tweaked API models when I was doing the search. The search was authenticated by passing a token and then getting some query typed by the user. I searched for that, I passed the token, got the query, then I filter that I don't have any problem, then I map to get the tweets, and then I transform this maybe, because that's what's coming there, to become a single. Then it's not nullable expected. Cool. Now we are transforming to Kotlin plus suspend functions. So what I have here is just the suspend modifier in the function. Then I am returning an either. That can be actually the result from Kotlin. For you, we didn't change anything, to be honest. Then the search, getting the response. Then you can see this imperative code of coroutines, searching that is happening right. And then just getting the tweets and passing the right side. That means that we have results to the either right side. And when we don't have any results, you're going to be passing to the left because there's going to be an exception coming from there. Cool. Then, because I want to pass a single, because the app layer, that is the repo, is expecting a single, I'm going to transform these to a single. And I'll use the Kotlin X coroutines RX2 library, because this, with this operator RX single, is going to return this single ready for the other layer to be used. Now, if I need to do the same with the database, I will just put the single return type here. As you can see, this query is as simple as just selecting all tweets that are in my tweet table by selecting the different IDs and then passing those in descending order, nothing else. Now I'm going to explain what's going on in the repo design and how I approached that from the very beginning. So at the very beginning, actually, because I came from the Java world, I was a bit confused. And also I tried to learn myself by having mistakes, because I think that's the best way to learn things. So I follow my Java approach, and you will discover why I call it the Java approach or naive approach. So the repo is going to be transformed and returning unobservable. So that's expected, Kotlin plus flow plus Java. Let's go for that. In the repo, we have the network data source that I described earlier, and the different tables I had for my database. That means the tweets database, plus the token query, plus the tweets associated to the query. And then the different mappers to transform the different models from the network to the database, and something called task threading that we'll see later in detail. So the functionality for this repo is actually searching for a query, being subscribed to the IO because it's an input-output operation, and then observed into the computation because maybe we need to do some computation later on. Then mapping those things. So I am transforming this either to become a list of tweets and then returning this with an observable. Then I am doing do on next for every single iteration of the stream. And this stream is actually doing just an update, deleting previous tweets, inserting new tweets, inserting a new query, and having this link between the tweets and the query, nothing else. Then when I am having this into the DB, I want to do sequentially flat maps because I want to retrieve those from the query. And I'm going to return those IDs that I mentioned earlier from this query in a form of list of tweets and returning the observable. But if we want to do the same approach with flow, we can do something very similar. We can just return a flow type. We can do the map exactly the same. Instead of do on next, we'll do on each. And we'll do the same operation, so I won't repeat them now. Then instead of flat map, we'll do flat map concat. Same operations right here. And then I will return this flow as a return type. We got it. Exactly the same, similar operators, exactly the same, to the exception of do and next, that is on each. And then for the DB, we return the flow instead. That's also possible with room, so why not to do it? Then, if we need to change the context, as we did with subscribe on, for flow, you'll need something like the operator flow on. That's going to be doing the same, but the difference is that this is going to be upstream. So you want to influence all the operators that you have on the top of flow on, it should be going to the very bottom. So that's why it's right here. Then that's streaming. I promise you that I will describe that. And this is something as simple as just a container or a wrapper with the different schedulers and the different types. As you can see here, I have computation, IO, main thread from the main thread of Android, and I am returning and exposing those things by the method because I want to mock them later for testing. Then if I need the same for coroutines, I'll do the same by just returning different types in those coroutine dispatchers because those are the things I need. But can we reuse those Java schedulers or to become dispatchers and then don't have 6 resources in memory, but just 3? That's actually quite possible. For instance, again, using data library, we can use the operator as coroutine dispatcher, and it's going to be converted to those schedulers to become those coroutine dispatchers. So we have that. We return those types, and we got it. Just 3 objects in memory, and we can use them as we need them. And now, with the same library, I will return an observable right here. And this is going to be the thing that is expecting my other layer, that is the use case. So that's going to be perfect. Now, let's go to a more pro kind of approach. When we are more familiar with coroutines and we think that we are doing the right thing, actually. So repository going to be using flow and suspend functions. So that means let's write some imperative code right here. We're going to do some lines. We are doing the same things. We are updating. And basically, we are converting things. In the end, we are retrieving those things back. And I am trying something here, but is that right? Is that even possible? So the wrapper of this function is a suspend function, and I am trying to send back a flow. But we say that the suspend is returning a one-shot operation, and flow is an open stream. So can we do that? Not really. And that was one of the mistakes because I didn't know what I was doing. And I tried that. Why not? So I failed and I learned. And what you can do instead, if you just want a one-shot operation, is returning a suspend function into this. That's all you need for that. And this is going to work. But we have more things what we can do. This is actually this database query returning a suspend function with a list tweet. But then going to flow cases, we can do also something like that. The flow builder going to be helping us to have different cases. And inside we can emit values because those are actually doing in a sequence. So you can do like different emissions. But in this case, I did only once. I did emit all. And this is actually very useful because emit all going to be returning all values. Let's say you have a poll being refreshed every 30 seconds. If you have this emitting all values, as soon as you have a new emission in the background, you're going to have this refresh into the UI as soon as possible because every 30 seconds, you're going to be refreshing this database from this network coming from the internet. And this is useful for that particular case. But actually, maybe we don't need that. We can just emit once, and then we have it. But if we have this case, we can just use spam functions instead. We don't need actually to use flow here as a return type. But then if we need to actually have an open stream because we want to do a kind of offline mechanism of catch, we can just return the values. We have the dirty values of the database, emitting those first. And then when we are retrieving this information from the network at this point, we refresh the DB, and then we emit those values back again. So we are emitting twice. That means we can use a flow because it's the purpose of it. Cool, and we can return an observable because that's the thing that we are expecting yet. Let's go to the use case and finishing the migration of the clean architecture side. Right here, we want to use Kotlin with flow and suspend functions. So let's see. Search with use case is composed by a repository and a test threading. As you can see here, initially, I use a use case with a search callback. And this contract, this interface, was including two methods: executing with the query as a parameter, that is the different queries of the user, and the callback that's going to be transmitting this information to the different entities for the view. Then the cancellation, because we need to make sure that we are not doing any memory leaks. Execute then gonna be responsible of initializing the callback. So in the loader, that's the pop-up we're gonna show first to the user, and then searching those things for the repository, and then subscribing, returning to the callback the good values, and if we have any problems, then we return that with the error one for the callback. Of course, we need to make sure that we are catching this disposable to cancel this later to make the dispose. And by that, we need to subscribe onto the computation thread for the different operations of the map that we need to do any transformations that's going to be happening right there. And observing into the UI, because the next step is just sending to the callback and synchronize with the UI. Then if we are doing this with Kotlin, this is quite the same. So in the loader, then when we are using coroutines, we use the scope.launch. The scope, if you remember, I explained you why I use that, UI dispatcher plus supervisor job. Then the repo for searching those things, the map operations, and the flow on that's going to be actually, again, down to the map because it's upstream. Then the catch, to catch any errors and then showing those to the user, we need to, and collecting the values to rendering things for the list. But this is actually super useful to me as well, because I think this is actually shorter. Instead of doing a collect, we can use on each right there, and then catching any things upstream that are happening on each or any other operators up to that, and then launch in with the scope. This is going to be equivalent, but we don't need to do a scope.launch because launch in going to do the same behind the scenes. Then we need to cancel that and making sure that static concurrency is happening. Then scope.cancel will do that for us. And actually, we need to nullify callbacks if we have them. Otherwise, we'll precisely have a memory leak. Then the same with the observables, going to be similar. Just disposing, making sure that we didn't dispose them earlier, and then making that null. And then obviously nullifying the callback as well. Now we have migrated this area from the clean architecture side. We don't need to return an observable anymore. We can just get rid of this helper and just return in a flow instead. Now let's go to the view delegate design. Right here for the hot observable. What is going on there is the view delegate is making sure that the presenter is starting. And by that, we also pass a public subject that is responsible of those mechanisms to happen. Then the listener of the view, I'm going to use the native search view from Android, and I'll pass to my listener the public subject. And then to the view, I will make sure that the listener is there for it to be used. Now, if we have this with channels, we'll return a flow later on. And we'll use inside the delegate listener preparation a channel flow block. This block, this builder, is super interesting because we can just say, define the listener inside, but also we have something interesting here. This channel object, this instance that you see here, is not actually declared anywhere, is it? So the thing is, channel flow is making this instance ready for us to use into this block. And with that, we don't need to make any cancellation of the channel because it's going to be automatically done by channel flow. Also, it provides a wait clause that is very helpful for listeners, because in this case, if we introduce the view set on query text listener and we say that it should be null after everything is done, we can just do it here and it's going to be done by this automatically. Then, if we need to do the same with subjects or Java in this case, for the cancellation, we need to actually invoke this view set on query text listener to null and do it when we need to do on destroy, let's say for the view. And then the disposable is going to be disposed, same way that earlier, and then canceling anything that we need for the presenter, and that means clean architecture side as well. So the listener is containing this public subject. When we go to ArcJava, this public subject is going to be used actually here in onQuery text change. Every time that the query is changing, we're going to pass this by the how to observable to be synchronized with the other coroutines. And then if we need to do the same with channels, it's as simple as just passing that thing coming from the block, and we'll receive a send channel. Send channel can use offer operator. Offer operator is synchronous. That means that as fast as we get it, it's going to be processed and be passed to the other coroutine that is expecting it. So now for ArcJava, we see that we used this public subject, we observe into the UI, we subscribe onto the computation, we do a depends of a little delay, we expect changes, so that means different values, and then filtering this query. Finally, subscribing to get the results or getting something to be showed to the user if there is any problem. If we do the same with channels or flows, here we are expecting a flow because it came from that block. So that means we're going to do the same operators, the bonds, destination change, filter. Those should be under the flow one because there's going to be into the computation dispatcher. Then we'll do on each to process this and start the query from that point, and then catching any problems right there. Again, catch is catching anything on the upstream. So on each, filter, any problems there, gonna be catch and code there. And then canceling the scope and the things happening in the presenter. But are we done with ArcJava? No, we still need to change that for the task threading migration. Because remember, we reuse some resources. So that means we don't need them anymore. We don't have any more ArcJava. So we use just the native coroutine dispatchers. We'll expose those things instead of the previous one. We remove the previous ones. We'll have, again, 3 resources in memory, and we'll reuse them and mock them if we need it. Then, to finalize this migration, synchronous communication design. That means going to the UI and actually passing the results back instead of callbacks with flow and Stateflow precisely. So I changed that use case. I created a new one called use case flow. The use case flow is going to remove anything related to the callback, and I'll expose this Stateflow for my shareholders. And Tweets UI state is a silly class that I describe in a moment. And the good thing, Stateflow can be passed across Java and Kotlin files. If you don't have yet migrated everything to Kotlin, that's going to be ideal to be used. So here we are. I started to initialize this Stateflow with a mutable Stateflow and the Tweets UI state that is nullable. Ideally, you wouldn't like to have this with a nullable state. You will precisely have all states with no null values. But for the sake of having this done as quick as possible and show you this use case, I just make this case like that. So I expose Tweets UI Stateflow to be used for the other shareholders. The good thing of Stateflow is that this single change is used by default. So no changes means no effect in Stateflow. And then in the seal class, I make sure that anything happening there is covered here. So if we have results or tweets for the UI to be rendered, then I will pass those here. If I have any error coming or any problem from the network or anything happen right there, I will have the message that I can show to the user or process later on if I need to. Then if I want to show one empty state, I'll have this to be used as well. And obviously, if I need to load something before showing and rendering those results, then I'll show this pop-up by means of this loading UI state. Cool. So right now we can just remove the callback from the show loader. I can just make sure that Stateflow is processing that by the setter value. So that's equivalent to set value function. And this is initializing, assigning this loading UI state. At the time this is happening, the loader will show up into the screen. So I'll search for the tweets. I'll do an H again, and I'll check that it's empty. If it's empty, I will just return this back in the Stateflow. But if it's not empty, I will wrap the results of the tweets and I will return them with the Stateflow. If I have any problem, I will catch that and I will show this error. I will pass this back as well. So that's done. I pass those Stateflows to the view. But now I need to process that for the view, because remember, this is still Java. So we cannot collect results from the view. So what I did here is a straight search tweets presenter with the use case. So basically the use case gonna be injected to my presenter, and I'll cancel anything happening in the use case when I need that with this method. That's the presenter with Java. And the presenter is right now doesn't need any callback. So I can just remove that, the initializing of that, and also the pass this callback to the use case. And I can expose Stateflow also here. Now I can pass this present Stateflow, so not pass, let's say expose. I am exposing this value. So the view delegate is it's getting this value from the presenter. And what is going on here is the delegate is helping the view. So that means that it's going to initialize the search view. And actually, the UI results, the tweets list UI, is equivalent to a fragment, but it could be an activity, custom view, anything you need to, that could be equivalent to that. So initializing the Stateflow, because I am exposing this get Stateflow there, coming from the presenter. And then in the Stateflow, gonna have this parameter there. This is again in Java. So the Stateflow handler is initializing the Stateflow plus the reference to the view. And I will process the collection of that from this Stateflow handler. As you can see here, into this from activity whatever, I am injecting the view delegate plus Stateflow handler. And in the Stateflow handler that is in the activity scope, I will initialize this. I will initialize the Stateflow plus the view, and then I will start the collection. For the collection, I will do the filtering if it's nullable. So we need to check it's not null. That makes sense. And then I will process different things for every iteration of the stream. So handling states for that. And then making sure that it's in the right scope. Now, this is a extension function for this tweets list UI. And with the Stateflow is loading a UI state, then I will show the loading. When it's getting some results, I will show the results. When I am getting empty UI state, I will show the empty UI state, and so on. So we have everything covered here, so we are safe to go on. Then for the Stateflow handler, you can cancel this and making sure that everything is stopped at the right time to avoid memory leaks. And then for the tweets list UI, exactly the same. When we're destroying the view, we need to make sure that we are canceling the different scopes, that we have it in the different ways and mechanisms. And yeah, that should be it. With that, we have the full Reactive app done with Flow and Stateflow. So that's pretty cool. Let's see some lessons learned that I felt were interesting at the time. For instance, exchangeable. What I mean by that? Exchangeable means that because this kind of black box mechanism I used, I was able to make sure that the different layers didn't have breaking changes by passing the value that this layer was expecting. That means if we pass this observable, this is what is expecting to the layer. If this layer is ready to use a flow, then we are passing this flow. So I was doing this step by step, and this helped a lot. So this library, making sure that I am passing singles or observables, is quite crucial. And also is helpful because you can also do the opposite way. You can change from singles to suspend functions, and yeah, from observables to flow. So you do in the other direction is also possible. So that's perfect. Stochastic concurrency is super cool. We can see that we have few advantages like this stochastic concurrency cancellation for everything under this scope, plus autocomplete of observables, plus back pressure if you need it. So that's very cool. But you're in the middle of this migration yourself. Probably you need to make sure that you are covering different cases, because if you are returning an observable from one of the things that you are transforming in the other inner layers, then you need to dispose this observable. You don't have stochastic concurrency despite you have coroutines in the deepest layer. So it's something to take into account because we don't have those advantages. Meanwhile, we are migrating. So we should be aware and careful. Then imperative against declarative programming. This is quite an interesting one because imperative probably something we feel that we do every day when we are programming, but declarative is the way we used to work with ArcJava. So when we migrate from ArcJava to suspend functions in this case, we are not really familiar with things we have to do, so we can make some mistakes like I did. So that's interesting. It's like you don't know what you are doing, but then you're gonna realize that, and probably the best practices are not the things you are expecting to be. So yeah, that can be something to think about. And then just to summarize pros and cons, so declarative, as I just mentioned, RxJava usually is quite declarative. You just put operators, you don't care about specifying things, but the purpose of that, what you want to achieve. But then if we use suspend functions, that's going to be imperative code. Flow is imperative because we are emitting values, but at the same time, when we are collecting things from the scope, that's declarative. So yeah, those things. Then for the lifecycle, RxJava needs to make sure that it's disposed in the different elements. Unless you have composite disposable, you have to do it manually one by one. And also you have different layers. You have to do it in every single layer, the cancellation. Unless you have other libraries on the top of RxJava that do that for you. Coroutines plus flow using stochastic concurrency is super cool. So we are covered to do that. And then for hybrid projects like this one I just exposed for you, Java and calling hybrid projects is good in RxJava, but if we have crazy cases with wildcards, maybe Rx calling gonna be more appropriate for that. That's up to you really to decide what is best in your case. And then if we use coroutines plus flow, it's perfect for calling and friends. If you don't have any in Java, you can just go with coroutines and flow. And yeah, that's basically my opinion for that. Next steps, wait for stable flow APIs, but I can say, and I can quite confirm, that we are in a very good shape to migrate to flow because almost everything is in stable version. Stateflows are in a stable version, Servflow as well. Operators of flow are in a stable version. The bonds is not yet ready to be stable, but it's going to be stabilized quite soon according to the plans. And yeah, some things like this block for channel wasn't stabilized yet, but probably can be. But yeah, it depends on the use case, but I think we are quite close to fully be stable with flow. So it's in a very good shape. So yeah, just if you want to wait for not have deprecation, you can wait, but it's in a good shape. Special thanks to Manuel for helping me to prepare this presentation in this second edition. That was from Droidconomia to now. And thank you for attending today. So you want to read more things, no worries. You will have the links of the different articles that I am explaining in detail, different things and different concepts. So if you got lost at some point, you can recap with those articles. Don't worry. Going to be in the slides later on for you to read. And if you have any questions, more than happy to answer them.
So, Raúl, thank you so much. If you folks have any questions, feel free to write them on the YouTube channel. And I guess Raúl will be very happy to answer them, considering he's in London and it's like 1 hour less, not so late. Otherwise, while people think about that, Raúl, I have one question. You've mentioned a few aspects that I think might correlate a little bit with functional programming, having objects like maybe and stuff. You are very engaged in Android as well. So what do you think about things like Arrow and these sort of libraries? Is this something like, I don't know, if you want to give us details from Twitter, that's fine. But otherwise, do you think this is something like we can use in productive apps, or does it make sense? Are we committing too much?
So basically, I use Arrow because it has a few operators that I feel are quite useful and understand a little bit what calling result offers, because I think it does offer both the positive and negative side. So we have covered both the right and the left side of this either operator. But if you want to go fully functional, I suppose it's a very good case to use. I didn't use that for production apps so far, but obviously it depends on your use case. Maybe for backend apps makes more sense. For Android apps, I don't have a strong opinion. If you have use cases where this is very useful, I don't see why not. But so far, the only experience I have with Arrow is actually with the either operator, which is super handy because you have more options than the result from calling. So yeah.
Okay, so I don't think so. We try to get you in, like, is Twitter using Arrow or anything like that? But
it's not. I can't say it's not.
Okay, it's not. But I think it's one of the things. Like I don't know. It's I think I personally work as a freelancer with many companies, and I think like trying to introduce this sort of framework, you mentioned them, and it's always a bit complicated to decide if you want to introduce them in any app that is going to production, right? And you don't know if you're getting married to the ground framework or not.
Yes, Ali, and also because it's difficult to understand a few concepts that maybe we are not so familiar in the mobile ecosystem. That's probably the most difficult thing, because if it's not only just to introduce a new library, but making sure that the team understands the purpose and what to do with things. If you need to educate your team, it's even more difficult.
Yeah, absolutely. Folks, if you have any other question, feel free to write here on YouTube channel. Otherwise, if you don't have any, I think you will be able to reach Raúl if you Google his name or you try to find him on Twitter. He should be very easily reachable. Okay, I think there are no more questions coming. Okay, then thanks from Philip Bonheimer.
Thank you.
Thank you so much, Raúl, for making the time. We really appreciate it. And I hope you can come again in the future to meet us.
Thank you for inviting me today, Enrique.
A pleasure. I think the Munich community is very happy to have you here. And Raúl, have a lot of fun. And otherwise, I guess we keep connected and we connect with you in the future.
Sure. See you.
Thank you. Bye-bye. So our last guest from today is Mohit Sarveiya. Mohit Sarveiya is a Kotlin Google developer expert. He has been working with Kotlin plugin for some time. I think you've been speaking and doing some research about this for some time.
Yeah, I've been using Meta and sharing my knowledge about it.
Right. He's based in New York, so Mohit, we really appreciate that you took the time to speak in this probably chaotic time for you, because it should be like 2 or 2:30 in New York. So thank you very much for waiting for us.
No problem.
And folks, here's our last participant today. Again, if you have any questions, just feel free to write it on our YouTube channel. And otherwise, as with the other speakers, if you Google his name, you'll be able to land on his Twitter or his contact page. If you want to share your screen, Mohit, I can
Sure.
add it to the... Okay, so Mohit, the stage is all yours.
Thank you, Enrique. Hi, everyone. My presentation is about how to write compiler plugins with a library called Arrow. So as Raúl was talking about Arrow, and Arrow has a lot of different libraries, Arrow Core, that gives you functional things such as either, etc. There's also a library called Meta, which was recently made to allow you to write compiler plugins and IDE plugins much more easily. And I'll show you examples of how to write different types of plugins. So what got me motivated to learn about Arrow is that I was looking for like an easier way to write compiler plugins, and also a way to use much more easier, like to use functional programming concepts such as lensing, optics, monad comprehensions, etc. in the with Kotlin, which is what Arrow provides you with those functional programming constructs. It surprises you the way to use them in a much more easier way. So let's first talk about how the Kotlin compiler works in an overview of it, and I'll share with you how Arrow supplements the compiler. So Arrow first you need some code, right, that you want to compile. And when you first phase that happens in the Kotlin compiler is that it takes your code and it converts it into an abstract syntax tree, into this different structure in which each node represents a particular element in your code, like a class, an import statement, some expression, etc. So when that code, after that phase, it goes into the analysis phase where it analyzes this tree and it adds in type information into it. So in this phase is when it will do type checking. It's going to check whether you're using types correctly, whether you're using subtyping correctly, etc. If there are any errors, it will surface them to you in the IDE. You'll see a message if there are any errors in your in the type checking phase. So after that, after it goes through that, it will go into lastly the core generation phase. So now in the Kotlin compiler, there is something called intermediate representation that it outputs to. From that, you could output to any platform that you want, like JS, JVM, or native. And then lastly, your code has been compiled to whatever platform that you're looking to compile it to. So Arrow is a library that supplements this compilation phase, gives you control into the different stages of the compilation process. So this library is still being, worked on, and I'll go over how it works. So in each step of the compilation phase, there was some byproduct, right? There was either in the parsing phase, there was an AST that was produced. In the analysis phase, there was type information that was produced, and then you have IR and the code generation phase. In each step, Arrow gives you hooks into each step of this process. So let me show you what I mean by that. So when your code is parsed, Arrow provides you with an API with something called quote template DSLs to be able to hook into this AST to search for a particular node, to be able to, to update that node and feed it back to the compiler to what you want it to be. It also gives you the ability in the type checking analysis phase to be able to specify a custom type checker that you want to do some custom logic with. And lastly, it provides you also with utilities to hook into IR. So those are the different ways that Arrow supplements all these different compilation phases. So now let me show you some really simple examples of how to use this library to write simple plugins. I'm going to start with the simplest, is a Hello World plugin. So suppose there are two steps to writing any type of plugin with this library. First is to write out your business logic, and the second to register your plugin. So let's look at these two steps. Suppose I want to write a very simple plugin where I have a method here called Hello World, and I want to generate some code in there, some print line statement that gives you a greeting. So when I run this code, it should generate this code right here. It should it should output this greeting when I call this method. I want to generate this. How do I do that? With error meta. So the first step to writing a compiler plugin is to create, what your plugin name would be, configure it, and then add your business logic in there. So I have created a field here called Hello World. Its type is CLI plugin, which is a type alias. And you can see it's a type alias to a plugin object. A plugin object has a name in there that you specify. What is the name of your plugin? And then you specify all of the different ways your plugin is going to hook into the Kotlin compiler. So let's first define that plugin object. I'm going to define the name of the plugin object, my plugin, which is Hello World. And second, so the way internally, when you look at this, you'll see is a string, my plugin name, and then I have a lambda block, which might look weird, but the way that this works is that internally it calls this operator, string.invoke. And you can see in there, it's creating this plugin object. So now I'm going to define different ways I'm going to hook into the compiler. So I'm going to hook into the parsing phase when it creates the AST. I'm going to do so with the meta method. And then I'm going to define something called extension phase, which are all the different ways I'm going to hook into the compiler. So the Kotlin, this arrow meta library provides you with a method called named function, and it allows you to search for a particular function in your source code. And you could define, what type of function you're looking for. I'm looking for a function whose name is Hello World. It could be something much more complicated based on your use case. When it finds this function, it gives it back to you so you could transform it. So this function, named function, is part of something called quote template DSL. In that DSL, there are different methods to find particular components like classes, expressions that you could transform. And they all follow this common pattern. You specify a filter that you're looking for. What are you looking for based on what you want, and it returns it back to you. So when you get the function back that matches this, it could be one or two functions. It doesn't really matter. So now I'm going to specify some transformation on that function. The transformation is called replace. So when I do that replace, I'm going to say I'm replacing this function, and I'm going to specify what my new declaration will be using a string template, as I have specified here. Obviously, this string template needs to be converted into objects that error meta could work with, which is what the .function.synthetic scope call does. So this is the simplest compiler plugin that you could create with this library. It's very simple. So how do you now register this compiler plugin? So in order to register it, you create a meta plugin object and inherit the meta class. It has a method called intercept. The return type of this method is a list of plugins that you want to use. So I want to register Hello World. It could be like more than one plugin that you could register. So when I create this plugin, I build it, and for JVM, I get a jar file that I could use in my library, or I could host it on Maven Central and use this. So then I could specify my plugin to use in my project like this as a compiler argument. So now when I run my plugin, when I run this code, you'll see that it will generate that println statement, and then you'll see in the console that it outputs it. So that's a very simple plugin, and those are the mechanics to use to build it. So the way this works is that when it gets converted to an AST, you'll be able to find a particular node in there and be able to basically apply that transformation and feed it back into the compiler. So now let's look at a little bit more of a complicated example, and also how to test plugins. We're gonna use everything that we just learned. So suppose that you had a function like this called calculate, and in this case it could be some complex calculation you're performing, and you want to be able to determine how long it takes. Be able to log basically have a debug log that shows you how long this function took. So you want to be able to suppose you had a use case where you want to annotate the function with debug log, and you want, when you annotate it, you want that function to basically log how long the execution took to whatever calculation you have. This is something simple that I have for the sake of simplicity. How do I write this plugin? So this is what I want to generate. I know I have my I have my original function body that I want to to execute, but around it I have basically, I want to log out the function name, the argument that I passed in. I want to have logic in there to determine how long it took to execute. So I have some logic to determine the current time. I have my original function body. After that, I determine the time it took to execute, and I log it out. So that right there is what I want to generate. So how do I do that? Write a plugin for that. So the strategy that I'm going to use is that this method is going to get converted into an AST. And I want to be able to find a particular function that has that log, that debug log, in this AST, and be able to do a transformation on it. So how do I do that? So I'm following here the same steps, the same template as I did before. I have the name of my plugin, debug log, and I'm using the meta method to specify how I'm going to hook into the compiler plugin. So I want to find a function. So I'm using the named function method. I want to find a function, and when it gives it back to me, I could transform it. So I need to specify a logic to determine, does the function have that annotation that I'm looking for, and does it meet my criteria? So I made a function to do that, an extension. And the way this extension works is that I want to match a function that has a particular signature, int param and a long return type. Now this could be something much more general for your use case if you want. I just made this for simplicity. You could generalize this. And I want to determine whether it has a particular annotation. So let me show you how I determine that. So you'll see this logic in like a lot of libraries like detect, etc. In here, I've made a function which takes in the annotations that you want to match, that you want to find. I convert that into a set, and then I have a lambda basically in which I'm determining so what annotations are there and do they match what I want. Every time all the annotations that you specify on a function get mapped to a KT annotation entry. And that gives me a lot of information, the name of it, etc., that I can match against. And then I'm returning whether it passes, whether it matches yes or no. So this is my method I'm using to determine whether I have the debug log annotation. So now this is my logic to filter the method, to filter what I'm looking for. So now I need to be able to transform it. And to transform it, I'm using this replace method here on transform a class object. And the way that I'm doing is that I have defined a replace function that takes in the function that I found, which is represented by C. And then in here is the code that I have to generate what I want. So first I pull in what's the information of the current function, the name of it, the value parameters, and the current body of the function. And I'm going to use that to generate my new code. So I'm doing it in a string template where I have basically my function, the name of it, the parameters, and the return type. I have basically my log statement that I want. I have the logic to determine the current time. Now I have the function body that's there right now, the logic that's in the function right now. And then I calculate the time it took to execute it, and I'll log that out. And then I return the result. So this is what I want to generate here. So in this function, that was a string template. Obviously, ArrowMeta provides you with an extension to convert that into some object that it could work with, which is provided by this extension over here that's in the ArrowMeta library. So that right there is a very simple plugin to be able to log the execution of a certain method that has a debug log annotation. So then lastly, I'm going to register this debug log compiler plugin here. And now let's run that plugin. When I run that plugin, you'll see in the console that It told me, the argument that I calculated, gave it an argument of 10, and then I outputted basically how long did that function take to run. That's what it outputted. So that's a use case. Now, how do we test this? So there is in the Arrow Meta library, there are different types of plugins, the modules. There are modules for building IDE plugins, compiler plugins, and there is also a testing utility module as utilities for testing. And let's look at how to do that. So the way you write your test is that you specify the source that your plugin, your test is going to act upon, which is this right here. So over here, as a string template, I specify what that source is that I want my test to act upon. And I convert it into a particular type of object using this extension over here, the source method over here. So then I specify what is the expected outcome that I want after my test runs? What is the generated code that I want? So now when you run this, the way you'll create this test is by using a method called compiler test, which allows you to set up basically the scaffolding for your test. It allows you to specify first what plugins are you testing. It could be more than one. I'm testing this debug log meta plugin that I just showed you. And it specifies what code will it act upon, which is what I specify here. And how will I match, what is the expected outcome that I want? Now I need to be able to run this test. And to do that, they provide you with a method called assert this. Internally, as you can see, it will basically run the plugin that you specify. It will run this scaffolding here, compiler test. And when it runs it, to run it, I'm going to call assert this, and I'm going to pass in my compiler test that I made, the setup of my test. So as your test runs, there is a lot of log statements that are outputted that helps you to understand what's happening. So let's look at that. So when I run my test, you'll see basically that it takes that code and it puts it into a file, source.kt, where each structure, each element of your source code gets converted into a particular object, as you can see here, the declarations, the annotation, etc. So then it runs basically your test on it, and then outputs what was generated by running your plugin, and you could see whether if there were any issues in there, and it will report them to you. So that right there is how you write a test using Arrow Meta. So now I want to talk about, I'll show you how do you combine different transformations together. We looked at how to do a replace, remove, but there are many more transformations. And we looked at how to do a replace, so look at how to do a remove. So you could search for, there in the quotes template DSL allows you, they have methods for searching for expressions, declarations, property, so many different things. So suppose I had a very simple use case where in this case, I want to remove this expression, this println statement. In order to do that, I follow the same step of defining my plugin as I did before. And I basically specify I'm going to search for a function. I'm going to search for a function called hello world. And when I get it back, I want to transform it by removing it. And to remove it, I'm basically going to do remove in that function. And I'm going to say, I want to remove this expression inside of it. It could be something else that you want to remove based on your use case. And this is a very simple, compiler plugin. So for removing a particular expression. So when I run this, you'll see that when I call this method now, you'll see that nothing gets outputted to the screen. So that's how you create a remove and your compiler plugin to remove something. What if you want to generate new sources like in a particular file based on the logic that exists right now? So suppose that you had a data class like user, and I want to generate basically some adapter. And this is like similar to a Mashi adapter and JSON like adapter. You could write a compiler plugin to generate those things, but they're already existing there, but just a use case that I wanted to show. So in this example, you may want to write logic to how do you deserialize it and serialize it. how do you generate this type of code in a new class? So I'm going to write my plugin like that. So I'm going to name my plugin adapter plugin, and I'm going to use the meta method in which I specify how I'm going to, do that transformation. So I want to find a particular type of class declaration, in my class, in my source code, and I want to find a particular class that has some property. Now there are different types of properties you can match with, like it's in a certain package, etc. So in this case, it's something simple. I went with like the name. So name is user of the class. How do you transform that? Generate some new source code. You could use transform.newSources. So transform is an object that has different static methods like new sources, remove, replace. So what this will do is basically, I want to generate this code over here. And over here is you can specify some complex logic depending on on your use case. And then you specify in which file do I want basically this source code to be generated in. And over here I'm doing the file name, which name the user class adapter underscore generated. So then the way this works is that when I run my plugin, when I run it, it's going to you're going to see that in this file it generates the logic, the adapter that I want, and you could add in any type of logic that you want for these methods, serialize and deserialize. So that's how you use transformation.newSources. So and how do you combine transformations together? And ArrowMeta provides a utility for that. So suppose that I want to have this very simple class and I want to do multiple transformations, not just one. So what I'm wanting to do is that I want to change the modifier here to public to private, and I also want to remove this method over here. How do I do that? So in order to do that, this is what my expected outcome should be. So in order to do that, I'm going to specify my plugin as I did before, like this. The name of it is Compose Transforms. And then I'm going to say I want to find a class declaration called simple class. And then I want to change the visibility of that. So the way that I'm going to do that is that this method here is an extension on compiler context. It takes in the class name, and the class declaration that you want to transform on. So I'm going to specify basically the declaration, which will basically do this transform.replace, and takes in, and I specify my new declaration as a string template, and I say I want my modifier to be private now, and it converts that string template to a particular type by calling .class.syntheticScope. So next step, I want to combine that by also removing that method for remove greeting. So the way you're supposed to operate on that declaration is by basically doing this remove over here. And I specify what method do I want to remove in the class, just like this. And I convert it to some expression using the expression in method extension. So this here does a remove. So how do I combine both of these together? So to combine both of them together, there's a plus operator that the library defines. And this operator takes in the two transformations that you want to do, and it combines them into a new type called transform.many. And transform.many basically encapsulate all those transformations you want to do into a list that it will operate your code on. It will apply those transformations one by one sequentially. So that right there is how you combine multiple transformations with ArrowMeta. So this is what my code will look at the end when I operate on that simple use case. So these are all the transformations that I want. All my examples were very simple, but you could write something much more complex, much more powerful, depending on your use case. So now I want to give an example. So far what we did is that we hooked into the parsing phase. But what if we want to hook into the type checking phase? You want to do some custom logic in the type checking phase. How do you do that? So suppose that you had a very simple example. You had two different types, and you want to do some, just perform some custom logic in the type checking phase. You want to define equality and subtyping. So In order to do that, the library provides you with a way to inject some logic into the type checking phase. And by using this method called type checker. And I have created a class called custom type checker where I will have my logic that I want to specify. So in the Kotlin embeddable compiler, you'll see that there is this class called new Kotlin type checker that provides you with an API to do this. It has two methods that you override. One of them is called is subtype of, which takes in two types, and you specify it returns a Boolean. You specify like one is subtype of the other. And over here, you could hook in and do some processing that you want. It also has a method for defining equality, and you could hook in whatever you want to do. So in the community, there is a example of a compiler plugin for dealing with units like meters, kilometers that you could check out, which basically has a custom type checker that it uses to make it easier to deal with units. And you could so this is called a refinement type plugin. I'll link it out in my slides to that plugin someone made in the community. Inside of the Kotlin, inside of the Arameta library, you'll see examples of custom type checker in the type proofs plugin. So check out those to learn more about how to use the custom type checker. So now, lastly, what I want to talk about are how to write IDE plugins. So it's the same process, and IDE plugins is writing IDE plugins with Arameta is powerful because it lets you to improve the developer experience when someone is using your API, using your library. So suppose that you had an example where you had some form of an architecture that you were using, whether it was architecture components or whatever architecture it is, and you want to improve the developer experience. So for example, like when someone uses the coroutines library, when the suspending method is called, you'll see an icon displayed right in the IDE. Suppose similarly you want to display some icon when someone refreshes some type of state, when something happens, if they're using some particular architecture. Suppose you want to display this icon whenever someone calls set state to indicate that this will update the state, this will refresh it. So how do I go about showing this icon for a particular type of method that you may use, someone may use as part of your API? So it's very similar. The difference here is that I'm going to create a object. It's going to be called IDE plugin. An IDE plugin basically is very similar to compiler plugin. It basically is a type alias, and you're basically creating a plugin object. We have the name of your plugin, and you also have what logic it will basically hook into the compiler. And which is very similar, as you can see, is this is going to call internally this operator to create this IDE plugin object. So in order to, I'm going to use the meta method, and internally I'm going to use a method called add line marker provider, which will allow me to do what I want. I'm going to specify the first argument, which is going to be the icon, basically a resource path to an icon that I want to display in my IDE plugin. And I want to display this for what type of KT object. In this case, KT name function. It could be KT name the class if you want. And it also allows you to render some message to give feedback on your API. Like someone hovers over that icon, you'll see a message in there called state will be updated by action in this case. And then you specify, I want to display this on a particular type of KT name function, but based on some property. The name of the function is set state. But it could be something much more complex. You could pull out information on that object, KT named object, and define it for something more complex. So this is a very, very simple IDE plugin that I have made. You can see there are parallels into how I go about building this when compared to a compiler plugin with Arameta. So then I need to also register this in a meta plugin, and this is how I'm going to do it. I return a list of IDE plugins. It could be more than one IDE plugin if I want. So when I run this code, you'll see that basically you'll see an icon there, and then when I hover over, you'll see a particular type of message that's displayed. So this creating IDE plugins is useful for improving the developer experience, and this library provides you with a good ways. You could do a lot more things in the IDE to improve the developer experience when someone is using your library, your architecture, etc. So there are examples. There actually was a PR opened 4 days ago for adding an optics plugin. So if you heard of lensing, for example, if I have like nested data class, like you have an employee class and you have inside of it, you have a class to represent their address, and then you want to update like nested objects. It provides you with a nice way to do that with lensing. And there's a plugin for that. There's a plugin for monad comprehensions currently, but that's also being updated. There's a good example of type proofs plugin that you could look at. So they also have a repository which has examples of plugins like similar to what I just showed you that you could check out. So I wrote a blog post and a couple of months ago on everything that I just covered. And I show you examples of how to write a plugin. I also have a repo called debug log meta arrow to show you an example what I showed in this presentation. So I want to lastly give a shout out to the Arrow team, to all the creators of the library, the contributors, Rachel, Raúl, Imran, Simon, and Jorge's, and they made a really great library. Provides you with a really nice API to create compiler plugins and IDE plugins, and it's being built as we speak, and it's just changing, it's updating. So if you're interested, if you have any questions that I can't answer or if I miss, you could also ask in the compiler Slack room. I made this Slack room about 4 years ago, and it has so many people now. Very active Slack room in the Kotlin Slack community. There's also an Error Meta Slack room that is, you could ask any questions about this library if you want in there, and the contributors will be very quick to answer your questions. And also these are some links to talks, more talks about Error Meta by the creators of this library that go more into, for example, the type proofs plugin. And I hope that was useful to you. I hope you explore Error Meta. Thank you for the opportunity. Thank you to Enrique for giving me the opportunity to present in this meetup. It means a lot to me, and to present with some great speakers like Raúl and Manuel it's great. Thank you.
Thank you so much, Mohit. I think I could say that most of the folks here have seen your work before. If you have any question, folks, that you want to drop to Mohit, feel free to do that. Otherwise, I think I will start. Mohit, you were mentioning this compiler test class. Where is that exactly defined?
So the compiler test class is defined in a module inside of Error Meta, which is just for testing. It's called Meta Testing Utilities. And inside of there is where it's defined and that you could use to test your plugins.
Okay, great. Philip is giving some applause here. So, folks, if you have any questions you want to ask, I actually might have a few questions about Android Arrow Meta. I think it's similar to the thing with Raúl. What are your feelings about? Well, one question from Philips Bornheimer: which IDEs does the IDE plugin works in?
It works with IntelliJ and Rich Studio. IntelliJ and Ender Studio. I think you could also extend it to any JetBrains IDE.
Actually, if you mention IntelliJ, I think that probably means like the JetBrains family, right? Like,
yeah. Currently, it's only Ender Studio and IntelliJ IDEA.
I might ask you the same question as I asked to Raúl. What do you think about Arrow in general as something that can be used for general software engineering purposes? Do you think functional programming is something that can be generally applied?
Yeah, so so many abstractions that it has is so useful, as we saw in the last talk with, for example, like using either, and I have used either, try, I have if you're like, for example, like a lot of people or some people are building apps using MBI where the state is immutable, and you may have state that's really nested. So something that's useful, manually you would want to like update your state, you may do like state whatever class dot copy, but lensing makes it much easier because they generate a lot of the different ways to update nested state, and it's an idea from Haskell. I think that I found that useful. Like you'll see so inside of Arrow there is a more state, for example, more state, which allows you to model your state that you could just, very similar to Redux, where you could update it using some actions. So it has a lot of the really great abstractions that you could use that I find very useful.
Okay. Yeah, I think in general, or that's my impression, like people in the industry generally are thinking like, is this functional programming for us? Should we include it in our, like very commercial app? Do we get any benefit from that?
Yeah, they would definitely, it would make your code testable. So in the community, Jorge Castillo has so many great videos and presentations on to answer that question you're asking, and it makes your code testable, understandable, and achieving separation of concerns, functional programming. So now with MVIs, you could it fits really well with it.
Okay. Folks, do you have any questions or anything you would like to speak with Mohit? Otherwise, Mohit, I would really like to thank you for taking the time to speak here. I'm very sure that the Munich community is very thankful for that. I hope we can have you in the future.
Yeah.
And you keep researching a lot on all the Kotlin compiler things you're doing. I think for the people that we don't have time, it's something amazing to see people that have been putting time on research, and we can learn from you.
Great.
And otherwise, folks, I think, well, if you want to, Philip Bornheimer writes, thanks for the lensing hint. I think if any of you wants to Google for Mohit Sarveiya, you'll surely find his Twitter account and his blog on Medium. He has been recently named Kotlin developer expert, if I'm right.
Yeah.
So yeah, I think it's one of the folks you want to follow if you want to stay updated into Kotlin game.
I had one more thing. Anyone also extensively use coroutines? If anyone wants help, you can reach out on Twitter. I'm willing to, help you or teach you one-on-one, and really enjoy, teaching. So, or writing your test or whatever questions that you have on coroutines.
That's a fantastic offer. I think we don't have every day the offer of a Kotlin developer expert offering help at our group. So
yeah.
Thank you so much, Mohit. I think it's very great to have you here. Again, I hope we can have you in the future again in another Kotlin groups event in Munich. And folks, if you want to search for Mohit, feel free to Google for him. Mohit, thank you so much. Have a fantastic day in New York. I think you have a few hours.
Yeah.
Let's keep in touch, and yeah, you're absolutely welcome anytime you want to be with us again.
Great. Thank you for having me. Thank you. Bye-bye.
Bye-bye.
Bye-bye.